Okay, unfortunately we didn't get the picture, but we've got a graph. We've got a couple of asymptotes here. We've got a horizontal asymptote down here. And then we've got this wiggly thing up here. And this is the graph of our function. Okay, so what we need to do, first of all, we ask you to estimate f of 3. Well, how do you estimate f of 3? Well, you go over here. We've got a scale on the graph. Okay, negative 200 to 300, negative 8 to 8. We find x equals 3. Now x equals 3 everywhere on this vertical line. Okay? Every point in this vertical line, the x-coordinate is 3. X-coordinate of this point over here looks like it's 1. X-coordinate of this point over here is 8. X-coordinate of any point above and below the x equals 3 point is 3. We draw a dotted line there, see where it intersects the curve, and then we see what the y-coordinate is. The y-coordinate, well, we just draw a dotted line over to the y-axis, and whatever the y-coordinate there is going to be the value of our function at 3. Because we say f of 3. Why is this y-coordinate f of 3? Because y equals f of x, that we set up here. Okay, that's our function. Y equals f of x. So f of 3 is the y value when x equals 3. Okay, the y value when x equals 3 is the value at the point where x equals 3. It's here, and we estimate that to be about negative 120. Here's 0, here's negative 200. Looks like about negative 120. You might think it's negative 100, negative 110, whatever you think. Then the estimate would be, the coordinates of this point would be 3, and our estimate of the y-coordinate is negative 120. Okay? Now, we want to find the average slope on the interval, negative 4 to 3. So we draw the interval from negative 4 to 3. That would be here to here. Okay, the interval negative 4, 3, the yellow interval, which would include the endpoints, and I thought I'd, where's my yellow chalk? Have it in my hand. Anyhow, we need to have a dot on this point, and a dot on this point, closed off, so it's a closed interval. Okay, so I should have done that. Thought I had it. Okay. Anyhow, there's your interval from negative 4 to 3. If we want the average slope of that interval, well, we take the point at this end, which we already have, negative 3, negative 20, at least we've estimated it, and we locate 4 here. If you got the graph in your hand, you can easily do this. You got the graph on paper. You find negative 4, it's halfway between 8 and 0, negative 8 and 0, and you project up here and over here, and you estimate that the y-coordinate looks like about 80. If this is 300, there's 80, 160, 240. Maybe I underestimated it. Maybe it should have been more like 90 or whatever, or 70. But anyhow, it's negative 480 according to my quick estimate. Then what do? You got this point and this point. If you want the average slope, you sketch the fundamental triangle. Draw the arrows, label its rise, you label its run, and you label its slope. So that's a process. And with that, as I said to the class, and I didn't have the camera on when I did all this, unfortunately, you go to problems 3 and 4 on the sheet I gave you on the first day. You understand this, and you do everything you can, and then we see what you still need to understand about these graphs. And there'll probably be something that we'll have to talk about, but I'll figure that out when I see your papers. Okay, very good.